Welcome! Today we're diving into a 1905 physics mystery that completely shattered classical science.
Let's think about this. What if a simple beam of light actually broke the laws of reality?
It's the photoelectric effect. Light hits metal and electrons shoot out. But classical physics totally failed to explain it. See, classical wave theory assumed that brighter, more intense light would give those escaping electrons way more kinetic energy.
But experiments showed zero change in energy when the light got brighter. Only the total electron count went up.
Wave theory completely broke down. It couldn't explain the missing energy, threshold limits, or the instant electron ejection.
This crisis sparked a massive turning point. Einstein swapped continuous classical waves for discrete quantum packets called photons.
He proposed light travels as these indivisible energy bundles, and a photon's energy depends entirely on its frequency. So intensity just means the quantity of photons, while frequency actually determines their energy. This was a game changer.
Imagine knocking down a wall that needs 10 joules. 5 weak, 2-joule hits won't do anything at all.
You need one massive 10-joule impact to shatter it. Light actually interacts with electrons using this exact rule.
This brings us to the work function. It's the strict, absolute minimum energy toll required to eject an electron.
It's an all-or-nothing exchange. One single photon transfers all its energy instantly to pay that exact toll.
It's a strict one-to-one deal. Multiple weak photons absolutely cannot pool their energy together to eject one electron.
So, if the energy per collision is capped, why did the current increase when the light got brighter?
While higher intensity simply means way more photons are hitting the metal. More collisions mean more ejected electrons.
But because the light's frequency didn't change, the energy of each individual photon remained exactly the same.
Now, this perfectly explains the threshold frequency paradox. What happens if the incoming light's frequency is too low?
If a photon's energy is lower than the work function toll, 0 electrons escape. Intensity doesn't matter here.
By proving light acts like particles, Einstein brilliantly solved every single failure of the classical wave theory. Light is a stream of quantum packets. If light hides a dual nature, what else is secretly quantum?